So welcome to week 3 of programming with C++. Now, in today's video, we'll be considering pointers, arrays, and structures. We'll be also demonstrating how uh, they work in a basic C++ program. So let's get right into it. So, what are pointers? A pointer is a variable that stores the address of another variable. So that is what pointers basically are. They store the addresses of another variable. Pointers can be used any data type at all. From int to string to bool, pointers can be used, even arrays. Pointers can be used in arrays. Let's see. Okay, so how then do we create a pointer? Well, the basic syntax for creating a pointer, or the structure for creating a pointer, is what I'll highlight right over here. Your data type, and then the asterisk symbol. Now, this asterisk symbol is known as a dereferencing symbol or the dereference symbol. It's very important. So you bring your data type, your dereference symbol, and then the name, right? The name of the pointer. That is what the name means. So an example is down here, int. That is the data type, int, and then the reference symbol, and then the name of the pointer, which is PTR. Assigning address to pointers. How do we assign address to pointers? Well, the syntax is once again very simple. So in this example, the person, or the example we see here, int val was initialized and given a value of 22. So when you come down, you see that he assigned an address to the pointer. What do you mean by that? You see over here, he defined a pointer, int reference symbol ptr. Ptr is the name of the pointer. The reference symbol, of course, has to come, and then the data type. Then he assigned an address to val, So what the symbol there means, the symbol attached to the val means address of. That is the address of operator. That is the address of operator. So this is the structure for assigning an address to pointers. So we have our int, our reference symbol, the name of the pointer, address of the variable or the name of the pointer. So that's what we see over there. Dereferencing a pointer. How do we dereference a pointer? We know that the asterisk symbol means the dereference symbol. So to dereference a pointer, we simply include the or attach the asterisk symbol to the name of the pointer. That is, in displaying, if you want to display, the value, the pointer is pointing to, we dereference the pointer. That is one function of the dereference symbol. So if you want to display the value a pointer is pointing to, we add or we attach the asterisk symbol to the pointer name, right? That's what we see here. So see out the reference symbol ptr. If you run this line of code over here, it will show you the value that pointer is pointing to at that particular time, right? Now, what do we see over here? When we come up above here, let me highlight it for you. This is the same, you know, line of code we viewed before, right? This is the same line of code we viewed before, and he is trying to show us the value the pointer is pointing to by dereferencing the pointer. That is the whole concept of dereferencing. So if you want to see or access the value present at the memory address pointed by the pointer, you dereference it, and this is the syntax. Once you um assign the address of the pointer, you dereference the pointer when trying to output it, so you get the value of or the value present in the memory address pointed by the pointer. Okay, modifying a pointer address. What do we mean by modifying a pointer address? Or a pointer can be modified to point to another address if it's of the same type. So for example, if you have int A and you have int B, int A and int B are of the same data type, right? So we can do multiple name declaration from week 2. So int A comma B, then we terminate it. Now that line of code means A and B are integer data types, right? Now we can modify a pointer to point to another address if it's of the same type. What that means is that if we are pointing to A, look at this, I'm highlighting it so that you see right now. This line of code means that there's a pointer pointing to the address of A. There's a pointer pointing to the address of A. That's what this line of code means. A pointer is pointing to the address of A, right? But since we also assigned B as an integer value or integer data type, we can modify the pointer to also point to the address of B. We can modify the pointer to also point to the address of B. So that is what we are trying to see. That's all for modifying a pointer address. So that is the code for modifying a pointer address. So let's demonstrate all what we have done on the pointers so far. All what we've done on the pointers so far. So we mentioned earlier that in order to initialize a pointer, the syntax is the data type, that is in this case int, the data type. Then from the data type we bring our the reference symbol, that is the asterisk symbol, and then the pointer name, so in this case ptr, then the address of operator, and then we bring the name of the variable. But we first need to even declare the variable, so let's declare any variable at all. Also, should I stick with x? Okay, let's stick with val. So let's first create an integer variable. So an integer variable called val, then we give it a value, we initialize it, so 25, we terminate it. Let's also terminate it over here, right? So yes, that is it. That is the initialization of a pointer, and also the initialization of a variable val, an integer variable called val. Okay, so if we want to output this, we said that pointers point to the memory address of the variable it's pointing to. So if we want to point to the memory address of val, then we simply do this. So cout, we are instructing the system that we want it to output something in the console. That is what the cout means. So cout, so we want it to point to the address, so ptr, then the end line. Okay, so what this line of code means is that we are instructing the system to output um, the address of val, that's what you are saying, the address of val. So when we run this code, let's quickly run this code. So yeah, as you can see, that's the address of val, over here, the address of val. Now if you want to display the value stored in val, or the value stored in val, we simply introduce the reference symbol. The reference symbol. So let's do that. The reference symbol. Then that means we are or we want the system to display the value stored in val. So let's quickly run this and see. 25. So that's as you can see. All right. Then what else? What else? We also discussed modifying a pointer address. Modifying a pointer address. So let's quickly look at that. So let's comment this. Okay. So to modify the pointer address, we need to first initialize any variable at all. So integer data type. Then in this case, let's use a and b so that it's simple for us. A comma b. Okay. So we've initialized a and b as integer data types, and let's see. So let's initialize it. Let's initialize and let's give them values. So a, let's say a is 65, b 70. Right. So let's go on ahead and point to the address of a. Okay. So you already know the structure. Int, the reference symbol, the name of the pointer, ptr, um, assignment operator, the address of a. All right. Let's terminate this. Oh, sorry. Let's terminate this. Okay. So right now, what we've done here is that we have given a pointer, right? Or we have created a pointer to point to the address of a. So if you want to point to the address of a, we follow the same syntax again. We tell the system we want to display the address of a at the console. So that's what we are doing. ptr. In this case, it's going to point to the address of a. Let's see. Oh, it says this. Oh, okay, sorry. Instead of the assignment operator, I introduced the minus sign. Okay, that should fix the problem. Okay, so this is pointing to the address of a. Now we want to modify the pointer address. We want the pointer to now point to the address of v. What do we do? What at all do we do? We simply just do this. ETR, the name of the pointer. Then we switch it to point to the address of v. Address of v. Yes, as easy as that. So now if you want to sorry, if you should run this code, it's going to display the address of b. Yes, it's going to display the address of b. Hold on. Okay, let me correct this. Okay, they should fix it. They should fix it. Oh, there's one error. Okay, let's see where the error. Okay, let's see where the error is from. Okay, so I think the error was that I didn't terminate um this line of code. Let me highlight it for you. Yeah, I didn't terminate this line of code. So this should tell you how very important it is to always terminate your line of code before moving to the next line. It can cause you errors. So let's quickly do that, right? And let's run this code. So now it will point to the address of b for us. What if you want to point to the value of b? What do? We dereference it. As simple as that. Just dereference it. When you reference it, it will point to the value of b. 78. What if you want to display the value of a? Okay. If you want to display the value of a, we simply let it, let me see. Okay. the reference symbol PTR. Okay. Um, let's see. So we can implement this as well. Yeah. Then voila. Okay. So we displayed the value of A. Okay. What else did we do? Let's see. Modify data sizes. Okay. Okay, I think that's about all what we did for pointers. Yeah, that's all what we do for pointers. So let's carry on. Data sizes of pointers. Now, for a 4-bit system, the data size allocated to the pointer is 8 bytes, and for a 32-bit system, the data size of a pointer is 4 bytes. To find the data size of pointers, you can also, run a code to do that. And as I mentioned in week 2, the size of keyword over here, the size of attached to the pointer. Now we first need to declare the pointers. We need to declare the pointers. So that's what we've done over here. Declared pointer 1, declared pointer 2. Now regardless of the data type, the size of the pointer is still the same, whether it is an int, whether it is a char data type, the size of the pointer remains the same. That's what we are trying to also demonstrate over here. That's why they use two different data types. Now oh sorry, close this. Okay, so size of pointer 1, size of pointer 2. This code will give you the size of each pointer, pointer 1, pointer 2, and I can guarantee you that it's the same, the same size, 8 bytes, 8 bytes. My system is a 64-bit system, so when I run this code, I should get 8 bytes as the results or displayed in the console. Special type pointers. Special type pointers. We have 4 different kinds of special type pointers. We have the wild pointers. The wild pointers. The wild pointers contains random memory address that may or may not be valid. So this is basically the ones that we're doing. This is basically the ones we're doing. And then the null pointers, they point to no valid memory location. They point to no valid memory location. And the void pointers points to value with no particular type. They point to value with no particular type. And then the dangling pointers points to either valid addresses, sorry, points to earlier valid addresses, even though referenced memory address is erased. So for dangling addresses, to simply put it, they point to deallocated memory, right, or undefined. Sorry, they point to deallocated memory. Yes, they point to deallocated memory. That is a memory that was previously there. Okay, let's move on to references. What at all are references? References or a reference works as an alias for an existing variable. So when we say an alias can mean another name, right? Another name, yes. So a reference works as another name for an existing variable, providing an alternative name for it and allowing you to work with the original data directly. That is a reference. Now, what's the difference between reference and pointers? Well, a pointer allows us to pass potentially large amounts of data around at low cost. Instead of copying the data, we simply pass its address to a pointer value. That is for a pointer, or that is the key difference here between a pointer and a reference. So, creating references, creating references, creating references. So, to create a reference, we use this reference declarator, previously known as the address of symbol. So in a pointer, this symbol means an address of operator, and over here or in references it means a reference declarator. So it is used to create a reference, and this is basically the structure. This is basically the structure, right? So T um reference declarator, ref segment operator, var, right? So to break this down, your data type, okay, is the T. Then you introduce the reference declarator. Then the reference can be any name of your choice. You can even use ref, right? So as long as you know indicate or show the reference declarator, then you can use any name at all to show that it's a reference to var. So over here, the ref we see over here, this ref, okay, is a reference to var. So now I've created a new name for var, that is ref. I've created a new name for var, that is ref. So we can say var's nickname is ref. Yes, the nickname of this var over here is ref. So another name for this var now has become the ref. That is what the referencing basically means, right? So let's try an example of referencing over here. So let's quickly comment all this. Let's comment all this. Okay. Now let's initialize any variable. Any variable. So let's say a, right? Int a. Fine. Okay. So we've initialized a variable of the integer data type, that is a, right? Now I want to give a new name, so I'll reference it, right? I'll reference it to a new name. Let's see. So per the syntax, we do this, sorry, the reference declarator, then z, then bring our assignment operator, then we bring our a. Yes. Okay. So what I have done here simply means that z is now the new name I've given to a. Z is now the new name I've given to A. So now watch this. I will tell the system I want to display Z. I want to display Z. Okay, no, let's first display A. Let's first display A. So what you are doing here is that we are displaying the value stored at A. The value stored at A. Let's see something. So right now, 25 as you see. Okay, let's ask the system to display the value stored at Z, and let's also see what will happen. You see that it's also 25. So as I said, Z is now a new name for A. So if I want to display the value at A, okay, I can either choose to let the system display the value at A by writing down A, or I can write down Z as well for the system to display the value at A, because Z is now A. Z is now a reference to A. Z is now A. Whatever is stored in A, I can access it by using Z, because Z is a reference to A. Z is another name for A. Now, what happens if I give a different value to Z? What happens? So let's do that. Let's do that. Alright, so Z, let's say 56. Don't that. Then we tell the system we want to display A. Let's display A and see something. Okay, so we are telling the system we want to, display the value at A. Now we know the value at A is 25, right? Good. But let's see what happens when we run the code. 56. The value stored at A is now 56. Why is that so, or why is it that way? Well, first of all, we referenced Z to A. So now A and Z are basically the same. A and Z are basically the same. And over here, we assigned a new value or a value to Z, that is 56. So what we've done is that we've now also assigned 56 to A. We've now assigned 56 to A. So the system will now ignore the 25 we initially assigned to A and store 56 at A. It will store 56 at A now. So it will ignore those 25 already in the memory allocation of A. It will ignore it and now store 56 A. It's now store 56 at A. So that is what the referencing is all about here. Referencing, that's all the referencing is all about. So we can tell it to display the value at Z and to give us the same thing. To give us the same thing. You see 56. So that is referencing. Okay, now let's move on to arrays. Arrays. What are arrays? An array contains multiple objects of identical types stored sequentially in memory. It contains multiple objects of identical types stored sequentially in memory. Individual objects in an array are called array elements. An array element can be addressed using index or subscript. Now, defining arrays. What is the syntax for defining an array? The data type, the name of the array, then the size. The size should be in this square brackets. Then our termination symbol. What we've done here is that we've declared an array. Now, if we want to initialize an array, let's see. Yes, this is the initialization of an array. So the same syntax, our data type, our array name, the size of the array, right, in square brackets, our assignment operator, then our curly braces, then we introduce our elements, our array elements, separated by commas, right? So the catch here is that if it's an int data type you use, then obviously the values in the array should be integer data types, right? The array element should be integer data types. If it's a string you use, the array element should be string data type, right? If you use float, the array element should be float. If you use bool, the array element should be bool. Any data type you use should correspond to the array element, right? That's the initialization of arrays. The index of arrays is basically, very simple. Um, all we are trying to say is that the array element starts from zero. The first array element, it starts from zero, right? So regardless of the value you see here, right? This is 30, this is 50, this is 80, right? Now, in trying to access the array elements here, when we mention one, when we type in one, it will give us 50. Why? Because the array elements, the indices of the array elements start from 0. So 30 is 0, 50 is 1, 80 is 2, 3, 4, 5, 6, 2, whatever size we give our array. So over here, the size we give it is 3, right? So that means 0, 1, 2, 0, 1, 2. 30 is 0, 50 is 1, 80 is 2. So if you want to access 80, we have to type 2. If you want to access 50, well, we have to type 1. If you want to access 30, we type 0. We will be learn how to access the arrays. So let's see. Yeah, that's basically yeah. Let's go down. Let's see the how that okay. Yeah. Multi-dimensional arrays. Multi-dimensional arrays. So we have 2D arrays and 3D arrays. 2D arrays are arrays with columns and rows. So these are basically you know matrices. Yes, these are basically matrices. Columns and rows. They consist of columns and rows. Arrays with columns and rows. These are the 2D arrays, right? So as we see here, they can be visualized as a table or matrix. Yes. So that is a 2D array. And a 3D array has rows, column, and depths. Rows, column, and depths. Rows, column, and depths. So that's the difference between a 3D and a 2D array. So let's quickly demonstrate that. Let's demonstrate that. Okay, so let's comment everything over here. Okay, so we are about to initialize an array. The syntax for doing that is the data type. So in this case, let's use int the name of the array. So let's go with test scores. Test scores. Test scores. Okay, test scores. Right. Then the size. What do you mean by the size? How big do you want our array to be? So our array should contain five values, and our assignment operator. Then we go on to introduce our array elements. Any values can do, so 30, comma 50, comma 60, comma 70, comma 0 to 5, 1, 2, 3, 4. Okay, there's another value, so 8, 5. Okay, so then we are done. Then we terminate it. Don't forget to terminate it. So this is basically an array we've initialized, right? Yes. So in order to see how the indexes of arrays work, let's try calling out our array elements. So to call out our array elements, we simply instruct the system we want to display whatever is in index 0. Index 0. How do we do it? Well, we write the name, or we type the name of the array, test score, test score, and then introduce our square brackets, then the index we want to access. Now take note, as I mentioned earlier on, the first value is index 0, the second value is index 1, third is 2, the fourth is 3, the fifth is 4. So we want to access third to index 0, right? Then we terminate it. So when we run this code, it will give us the value at index 0, which is 30. Yes, that's what we see over there, 30. What if you want to access 80? What if you want to access 80? 80 is 1, 2, 3, 4, 5. So index 4. Index 4. Index 4. So we put in 4. Let's see. 80, right? So that is how the indexes of arrays work. We also talked about 2D and 3D arrays. Let's also see how that works. 2D and 3D arrays. So let's comment this. Let's comment this. Okay. Okay. So the syntax for that is basically the same. Basically the same. Just that they have rows and columns. So the sizes would be 2 instead of 1. The sizes will be 2 instead of 1. You will see what I'm talking about very in a moment. So our int, the name, let's go with test. Let's go with test here. Let's go with test. Now the size, as I mentioned earlier on, because a 2D array basically, has what am I doing here? So alright, so because a 2D array basically has row and a row and a column, right? Our sizes will be 2 instead of 1. So you see, in our previous array we created, the size was only 1 because it wasn't a multi-dimensional array, right? So the size was only 1. Now this is a multi-dimensional array. That is a 2D array. So a 2D array has rows and columns, so our sizes will be 2, right? So this is basically, think of this like you are writing a matrix, right? A matrix contains rows and columns, right? A matrix have sizes, right? So let's see. Okay, let's give this a proper name. Let's see. This is matrix A. So for better understanding, matrix A. Matrix A. All right. So matrix A. Okay, the size of matrix A is a 2 by 2 matrix. So what do you mean by 2 by 2? Our row is 2, our column is 2. That is what we've done over here. Our assignment to later. Then we can proceed to give values to our 2D array, right? So let's give it value. So let's say 1 comma 2, right? Now the reason why I introduce a second bracket is because they contain rows and columns, right? We are trying to show or establish that. So our one or our first, okay, let's say our first row is 1 and 2. That's row 1. 1 and 2 is row 1. Now let's go on ahead to introduce the next set of values, 3 comma 4. Now 3 comma 4 is our second row. So our first row is 1 comma 2. Our second row is 3 comma 4. Our first column is 1 and 3. That is column 1. Our second column is 2 and 4. So let me structure this well so that you can understand what I'm trying to say, right? Yes, can it work? Okay, bring it here so that it will look more of a matrix for you, right? So yes, as you can see, it's not done. Okay, so this is basically a matrix A, right? The size of matrix A is a 2 by 2 matrix, and the contents of matrix A is 1, 2, 3, 4. Now, our first row is 1, 2, our second row is 3, 4, our first column is 1, 3, second column is 2, 4. How do we access values here? Let's see that. So, see out, we instruct the system that we want to let me quickly do this. Okay, we instruct the system that we want to display whatever is in. For this case, let's go with row 1 column 1 so that we it's very simple for us. Row 1 column 1. This works just as how matrices work. So we see that for matrices, we want to pick a value in a matrix, right? We go according to the row and the column of the value. So one is the position of one is row 1 column 1, row 1 column 1, row 1 column 1. So that is what we are doing. So matrix A, we write our the name of the matrix, that's matrix A. Then we indicate the position of the matrix we want to show, or the index the matrix we want to show. Note that we are using the indexes here for an easier reference, right? Because the indexes are what place a major role in arrays. So to show what is in row 1 column 1, we know that the first number has the index of 0, the second number has the index of 1, the third 2, the fourth 3. So since we want to show 1 or whatever is in index 0, which is 1, we go ahead and say we introduce our square brackets, then we use our knowledge of matrix, right? So 1 is in row 1 column 1, the position of 1 is row 1 column 1. Now since we are dealing with indexes here, row 1 is 0. Row 1 is 0 because the first value, row 1 is 0. So we put that over there. Column 1 is also 0 because 1 is still the first value. So, sorry. So we do that here. Okay. Yeah. Then we terminate. Now when we run this code, let's see what happens. Since there's an error, we can just leave the errors. Okay. Once again, the error was that we didn't bring our termination symbol, So I've brought the termination symbol over here. Yeah, over here. So let's go ahead and run this code. Okay, one. So 2D matrices, 2D arrays work like matrices. All right. And then we also have 3D arrays, which have row, columns, and depths, right? So that one, let's also show how that works. Just add another size, right? So row, column, and then depth. They are in that order. They are in that order. Row, column, and depth. So depth can also be 2, right? Then it will mean that the values here will have to be three sets of values. So 1, comma 2, 3, comma 4. Then we can introduce something like 5, comma 6, so that it corresponds to the fact that we've made it a 3D array, right? Okay, let's move on to struct. What is a struct? A struct is a sequence of elements of arbitrary types. So they are used to create user-defined data types, right? So um the basic structure of extract is what has been done over here for us. So the name of the extract, then the type, then the member, the type and the member. So extract contains data type and members, right? Or extract contains members. The members are or the members have data types. So that is the structure of extract. So let's move on to creating the extract variable. Now after creating extract, we go ahead and create extract variable. What is the syntax for extract variable? Once again, the name of the extract we used to create the extract, and then the variable name. The variable name can be any name at all. Name at all we decide to give the extract. So that is the syntax for creating the extract variable. Now let's go ahead and look at creating extract variable with definition. Creating extract variable with definition. So after creating our extract variable, we then go ahead to introduce members into the extract variable. These members also have data types as well. They have data types as well. And then to access extract, we simply use the variable name that we assign to the extract variable and then the member name, right? So an example is down here, julia.age, right? Let me see if there's a clearer example over here. Okay, there isn't very clear example. Okay, let me just demonstrate it. So we are going to create extract. So let me comment all this. So mind you, the extract is actually created in the global scope. So let's do that. So to create extract, the syntax is this. So extract, then the name of the extract. So new record. Let's go with new record. New record. Then curly braces. So we list the members. Each member has a data type. So int age, int uh, let's go with house number, house number. and then string name. So we created our struct called new record. We created a struct called new record. Now let's go on ahead to access the struct. Now to access the struct, we need to this so the struct, right, and then the name of the structs we used. So I'm sorry, the name of the struct we use, that is new record, new record. Then the variable name. So it can be any name at all. The variable name can be any name at all. So let's go with uh let's go with king. King. Yeah, king. Let's go king. Yeah, king. Then we terminate it. Then let's move down. So now we can go on ahead to access the members of the struct called new record. So how do we do that? So the variable name king, then dot, then the particular member. So in this case, age. Then what do? We give it a value. So 25. We do same for house number, king, sorry, king dot house number. Then we also assign the house number 47. Then king dot name, king dot name. We also assign a name. So King Solomon. Then 10 minutes. Right. So we've successfully accessed the extract that we created. So if you want to display it, we simply come down and extract the system that we want to display. Want to display king's name. So we go king.name, king.name, and go ahead to yes, then we go ahead to run this code. Oh yeah, sorry. Let's fix the error. So the error was that name is a string, data type, and I did not put king's name in double quotes. Remember our lesson from week 2. For string data type, we need to put whatever it is in double quotes. So that is the error. So King Solomon, yes, that is king's name you displayed. If you want to display king's age, we simply just instruct the system that we want to display king's age. So age. How have I done? Okay, let's correct that. I did not know what I was doing. Okay, so we corrected it. We simply change it over here. Yes, so king age. Right. So 25. If you want to display king's house number, we simply do that. So we can move the age and put in house number. House house number 7. Okay, so that's the struct. Now let's move on to union. Union is also basically like struct. It's basically the same thing, the same syntax. the same everything, just that we use union instead of struct. So let's also look at that. So over here, instead of struct, we replace it with union, union, union. Yes. So now everything is just like everything about union is just like struct. Just that instead of struct, we use union, right? Now we can go on ahead to also run this code. Okay, there's an error. Let's see what the error. All right, so um, there are some few things we need to know about union, right? Although it's basically the same syntax as struct, but there are some few things that we cannot do in union. So, for instance, we cannot introduce a string data type in union. It doesn't recognize string data type, right? So that is probably why there's an error. So let me change that. So let's say char, char, yes, char, char gender. Those genders are usually single letters. So then let's go on to run this code. Okay, sorry, we need to remove this because we removed the string data type from there. So we need to change this. Yes, it doesn't recognize what you've done over here. So we then introduce gender. Assignment to put it down. Then single quotes, M, yes. So 77, that is our um yeah, okay, yeah, for I forgot to mention that for union, yes, for union it can only display one thing at a time, one thing at a time. So if you do not comment the others, it is not going to display the correct value for you. Not going to display the correct value for you. So let's look at that. So now let's run this again. Alright, 25. So you see initially it displayed 77. I wanted to show you something about the union. Um, Initially it displayed 77 because we didn't comment the other members. Union can only, you know, or only one member can be accessed in the union at a time. So if you want to access age, then you need to comment the rest of the members so that you can access age and age only. That is why initially it gave us 77 because the other members were not commented or were not excluded. But after we excluded them, we got to our value or we got the value we wanted, that is 25. So that is all for union and struct. Let's move on to enumeration. 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 Now, what at all is enumeration? Well, enumeration are user-defined data types that allow you to assign names to integer constants, making code more readable and maintainable, right? So they are particularly useful when a variable can only take one of a predefined set of values. So enumeration is basically used to assign names to integer constants, right? So we have two types of enumerations, the enum class and the plain enums. So for enum class, they use classes for defining the enumerations. So an example is what you see over here. So over here, the name of this enum class is called color. And we have red, green, blue, red, green, blue. So it defines an enumeration called color as I mentioned here. The enumerations are red, green, and blue. Now for the plain enums, we have an unnamed plain enum. An unnamed plain enum is used when a set of integer constants are needed rather than the type to use for a variable. So a quick illustration is shown over here. Now over here, the name the name of the enum which is enum, then the contents. red, blue, green. Now over here the person assign integers to these colors. So red is one, blue is two, green is three. But by default, right, if you are to just write them down as colors, red, blue, green, by default, from our knowledge from arrays, right? Red should be zero, blue should be one, three should be sorry, green should be two. Yes, due to indexes. We've learned how indexes work. They start from zero. So the first value will be zero, the second value will be one, third value will be two. So if by default, if the user hadn't assigned integers to these colors, it would have been red being zero, blue being one, green being two. Okay. So now when you go on to display this at the console, what you'll be getting will not be red. What you'll be getting will not be red, but rather one. Because we said that plain enums are used when a set of integer constants are needed rather than a type. So over here, we need an integer constant, not the color. We need the integer constant. That is why they are the person assigned these values or these integers to the colors. So if you are to display red, what you get at the console is one. If you have to display blue, what you get at the console is two. If you have to display um green, what you get at the console is three. So that is all for week three. That's all for week three. So um, we're looking forward to week four.